So now let's push this a little bit further. So we can work out the number of arrangements of n distinct objects, but we can change this problem a little bit. So let's look at the following example. So in this example, we're given 7 letters, right? The letters of the word Ireland, and they're all distinct letters. There is no letter repeated in that word. And we're asked to calculate the number of 3-letter arrangements that we can create from those letters. So now we're not arranging all 7, we're just arranging 3 letters from 7. So how do we do this? Well, the same idea of using the fundamental principle of counting applies here. So here's our solution. We're going to count 3-letter arrangements. So we think of 3 boxes representing the letters of our arrangement, and we count the number of choices in each box. So in the first box we have 7 choices, and in the second box we have 6 choices, and in the third box we have 5 choices, because when we go from the first to the second, we've used up one of our letters, so we're down to 6, and then when we get to the third box, we've used up 2 of our letters, so we've only got 5 letters left to choose from. So now the fundamental principle of counting tells us that we just multiply to get the total number of choices. So 7 times 6 is 42, and 42 times 5 is 210. So we've got 210 3-letter arrangements that we can create from the letters Ireland. Now, let's try and generalize this a little bit. So this problem suggests a more general problem. So rather than just 3 and 7, we could just allow those numbers to be variables. So we can ask the question, how many arrangements of OR objects can we create given n objects to choose from? So in the previous example, the OR was 3 and the n was 7. Right? We had 7 letters to choose from and we were making 3-letter arrangements. Now we want a more general formula. But the same principle applies. So we use the fundamental principle of counting, and so we just have boxes that we have to fill. So how many boxes do we have? Well, we have OR boxes. We're making arrangements of OR objects. So we have OR boxes, but we don't know how big OR is, so we have a bunch of boxes with some dots in between because we have some unspecified number of boxes. So there's OR boxes. And then we have n objects to choose from, so how many choices can we put in each box? So now we have to count these choices carefully. So the first box, it's easy, right? We have n objects to choose from, so we have n choices there. So let's put n in here. Now when we get to the second box, we've used up one choice, so we have n minus 1. We get to the third box, we have n minus 2. Okay, so now we keep going until we get to the orth box. So this is the orth box. So now we have to be a little bit careful here. It might be tempting to say, okay, we've got n minus or choices left, but that's actually wrong. If you think about it, right, in the first box, we had n choices, so that's n minus 0. And in the second box, we had n minus 1 choice. So this was the first box here, right? So first box, second box, third box. Okay, so now look, we had n choices, or n minus 0, so I'll write that as n minus 0. So what I want you to do here is to observe the pattern here. When there's a 1 here, the first box, we have a 0 here. When there's a 2 here, there's a 1 here. When there's a 3 here, there's a 2 here. So by the time we get to the orth box, we're going to have n minus or minus 1. So n minus or minus 1. Okay, so that's the number of choices we have for the orth box. Because this number here, inside the box, the number that we subtract from n, is going to be 1 less than the count of the box. Okay, so that tells us the number of choices in each box. And now fundamental principle of counting says that we just have to multiply to get the total number of choices. So times, we just put times in here. So the number of arrangements with OR objects, given n objects to choose from, is this expression here. It's n times n minus 1 times n minus 2, all the way down to this number that we got here, which is n minus brackets or minus 1. If we get rid of the brackets, that's the same as n minus or plus 1. So that's kind of like the factorial expression, except that instead of continuing our product all the way down to 2 times 1, we stop here at n minus r plus 1. So now this thing here on the right hand side, this expression here, that has a name too. And the notation for that is NPR. So NPR stands for the number of arrangements with R objects given n objects to choose from. And this is the formula for it. Now we can relate that to factorials. Let's take our example from above here where we had n was 7 and r was 3. So we were looking at 7p3. So we had 7p3, and we worked out that that was 7 times 6 times 5. Now we can relate this to factorials in the following way. So we have 7 times 6 times 5. Now if we wanted the factorial, we'd continue to multiply by 4 times 3 times 2 times 1. But these last 4 terms here, we want to cancel them off, right? So we could just do that by dividing by 4 times 3 times 2 times 1. Okay, and you see that this equation here is true, right? Because the 4, the 3, the 2, and the 1 cancel off, and we're just left with 7 times 6 times 5. But the point of doing it that way is that if you look at the top here, we have 7 factorial. And if you look at the bottom, we've got 4 factorial. And 4 is really the same as 7 minus 3. So we have 7 factorial over 7 minus 3 factorial. So look here, we have a 7 and a 7 here. And here we have the 3, which appears here. So this pattern generalizes to NPR. If you think about it, NPR in general, NPR is just going to be n factorial divided by n minus r factorial. So that gives us a way to calculate these numbers of these types of arrangements using factorials. So let's finish this lesson with an example of this. So here's an example similar to the one that we had before. We're asking for the number of 3-letter arrangements that we can make from the letters of the word Dublin. So those letters are all different, so our formula works in this case. So the answer, using our NPR notation, is just going to be 6, because that's the total number of letters, P3. Because we want to make 3-letter arrangements. So in this case, the n is 6 and the r is 3. And we just worked out that that's the same as 6 factorial divided by 6 minus 3 factorial. Or that's the same as 6 times 5 times 4 times 3 times 2 times 1 divided by 3 factorial, which is 3 times 2 times 1. So that's 6 times 5 times 4. And then the 3, 2, and 1 cancel off. And now we calculate 6 times 5 is 30, and multiply that by 4, and we get 120. So the answer there is 120. Okay, so that's how we use factorials to calculate numbers of arrangements.